Hi there everybody, thanks for tuning in, hope you're doing well, and this video will hopefully help you with some of the problems you've been recently assigned that are dealing with exponential decay and especially with half-life. So let's take a look at an example that I picked actually straight out of the book. Didn't use much imagination in coming up with anything here, just thought I'd pick a straightforward example of using half-life, and just to show you a couple of the particulars on how you use the half-life in the equation. So here's the problem. Half-life of something called polonium-210 is 140 days. Write a function that models the amount of polonium-210 after T days if the initial sample is 300 milligrams. Okay, so here's the problem, and if you will recall, our model that we use for exponential growth looks like that. It's just like the growth model, except that the exponent is negative. N of t equals n sub 0 times e to the negative rt. So there's our model. So if we're supposed to write a function, then it should look like that. It should start off with n of t. It's a function of time. And so the first thing we need is the n sub 0, and that is right there. The initial sample is 300 milligrams. That's what n sub 0 is. So 300 and then times e, and then our challenge really in this problem, the only real challenge is to figure out what r is. And if you recall, we went through this quickly in class today. I went through the algebra leading us to this little half-life formula, and I'm not going to do that here in this video. We're going to keep it kind of short and sweet. But the formula that we'll use here is right here. The rate is the natural log of 2 divided by the half-life. Okay, and so the half-life being 140 days means that we are going to put in natural log of 2 divided by 140. So this is going to give us r for the equation. We get about 0.00495 from letting our calculator handle that little division problem. And just keep in mind that, so that's how we get r, is natural log of 2 divided by the half-life. And we got to make sure that when you put it into the actual function that it is a negative value, because this is decay. The exponent being negative means it's getting smaller over time. Okay, so there's our function. We're done. We did it. Yay. Now we're going to use the function to answer a question. Okay, so here's the question. If you started off with 200 milligrams, how long will it take? I'm sorry, started with 300 milligrams. How long will it take for that sample to decay down to 200 milligrams? Okay, 300 down to 200. And once again, the information about this problem says that the half-life is 140 days. So half of 300 is only 150 milligrams. So this is more than that, which means that if you think about this, it should be less than one half-life to get down to 200, because it's not going all the way down to half of its initial amount. So we should come up with a number here that is less than 140, somewhere less. But how much less? Well, we're going to have to do some work to figure that out. Okay, so we're going to use 200 milligrams as kind of our target. That's what n of t ends up being. All right, so that's the only thing that we have to replace into the function that we just wrote, is 200 in place of n of t. And now we're just going to solve for t, of course. So we do our normal algebraic procedures here, nothing too fancy really. We divide by 300, that would be the first thing to do, and you get 2/3 equals e to the negative 0.00495t. And then our special trick here is to take the natural log of both sides. And I can rewrite the right-hand side there, bringing the exponent down as a coefficient of the natural log of e. And of course, here's where a really nice thing happens, because the natural log of e equals 1, and so it just disappears. And so we've got the natural log of 2/3 equaling this number, negative 0.00495t, approximately. And all we have to do to solve for t is divide. So we just take that natural log, divide by that number, and we get t is approximately 82 days. It's like about 81.9 days. Okay, well that sort of is consistent with our estimate, because we said earlier that it has to be something less than 150, and 82 is less than 150, so I guess that is a reasonable estimate. Here's another way that we can kind of check our work, because you know, it's good to do that. here's the graph that I drew of the function y equals 300 times e to the negative 0.00495x. That's what the curve looks like, this swooping down curve. And that point where the little red lines are crossed, that is approximately at the point 82, 200. And so that's good. 82 days, that's time on the horizontal scale. 82 days is about 200 on the vertical scale, about 200 milligrams. So the graph totally backs up our work. And so I'd say we got the right answer. It's about 82 days. Okay, hope you enjoyed that. Bye-bye.